Everybody there. All right, so we'll start here. Let's see. So welcome, scholars. Hopefully everyone had a good weekend. I'm glad to have you here. For anybody that's coming late, I'll check attendance again at the 15-minute mark. So if your brothers are like in the waiting room, just tell them to stay there until the 15-minute mark, and I'll do a second wave, at that time. No real major announcements other than, we're at the top of week 7. So what that means is that, essentially this Sunday, exam 2 is going to become available, right? So it'll become available this Sunday, and then you'll have access to it for like 7 days where you can earn up to 100%. But then after the due date, the highest you can earn is a 90, right? It's a 10% late penalty after the due date. As usual, if you have questions, feel free to unmute yourself to get my attention or type in the chat. I do monitor the chat. Also, if you've emailed me and I haven't replied, just remind me, just bring it up at the end of class and we could talk about it. If needed, I can make like a private room, but yeah, just bring it up at the end, okay? So today, let me see something. See if I can get it to work. Oh, let's go like this. View, single page. Oh, maybe that does it too. Okay. All right, so let's see. So we're going to be wrapping up chapter 1 on graphs and functions, and we're going to be working on section 1.6, combining functions and composite functions. A few objectives. 1, we like to define basic operation on functions. 2, form composite functions. 3, find the domain of a composite function. 4, decompose a function. And 5, apply composition to practical problems. Okay. So we have this over the sum, difference, product, and quotient of functions. Let f and g be 2 functions. The sum, f plus g, the difference, f minus g, the product, f times g, and the quotient, f divided by g, are functions whose domain consists of those values of x that are common to the domains of f and g, except for f divided by g, where all values of x where g of x equals 0 must be excluded. These functions are defined as follows. Let's just look at the definition. So 1, the sum is going to be f plus g of x. It's just going to be f of x plus g of x. All right. 2, the difference, f minus g of x, is going to be f of x minus g of x. 3, the product is going to be f times g of x, which is just f of x times g of x. And 4, the quotient, f divided by g of x, is f of x divided by g of x, provided g of x is not 0. So give me a moment. Yeah, okay. So let me see. A common error here, when students see the notation in this form, they see that and they think it's multiplication. And I've seen where students try to distribute x's like that. This is not multiplication, right? This just means the function f plus the function g, right? Again, this is not multiplication. This just means f minus g. That's it. This one is one product, but do not introduce an additional x. Again, students see this and they try to distribute an x. This is function notation, not arithmetic or anything. So this just means f of x times g of x, just f times g. This just means f divided by g. Okay. So again, the common error is students try to do this. That's not what's going on here. Okay. So, okay, where is oh, wait a minute, we're missing some stuff. Let's delete. Oh, you know what? I know what's going on. I was like, why does it look like that? There it is. Okay, so given this f and this g, find each of the following. F minus g of 4, f divided by g of 3, so on and so on, right? So for A, f minus g of 4, what that means is you just find f of 4, you just find g of 4, and then you subtract your answers, right? So if we plug 4 into f, that's going to be 16 minus 24, which is a negative 8, plus 8 is going to give us 0. So f of 4 is 0. G of 4 is 2. So then 0 minus 2, that result's going to be negative 2. Okay. So then for B, f divided by g of 3 just means f of 3 divided by g of 3. So f of 3, let me see, that's a 9. Minus 18 is negative 9, plus 8 is a negative 1. G of 3 is 1. So negative 1 divided by 1 is ultimately negative 1. Okay. So then C, yeah, let's go ahead and do it. So then f plus g of x, so basically it just means f of x plus g of x. So we can combine like terms. I'm just saying the function f plus the function g, where I combine like terms. So the x squared is by itself. There's no like term with it, so it just persists. Negative 6x plus 1x is going to be a negative 5x. Oh, come on. It's going to be a negative 5x. And then 8 plus negative 2 is going to be plus 6. Okay. For D, f minus g of x. So f of x minus g of x. And when we do that minus g of x, we need to distribute a negative. Right? So we're going to have x squared. If we distribute a negative into g, that's going to be what? If we distribute the negative and then combine the like terms, it's going to be a negative 6 plus negative 1 to give us a negative 7x. Okay. And then 8 plus 2 ends up being 10. And that's as far as we can take that. Okay, so I didn't like write out everything. We have it. It's in the prepared notes on the next slide, so I'm going to piggyback on that. I'm also going to use my prepared notes for part E, just because. But for E, we're basically doing f times g of x, and so we need to distribute, right? So it's like FOIL. This x needs to multiply by each term, right? Each of those terms need to be multiplied by x, and each term needs to be multiplied by negative 2. Okay. And then when we're done doing that, we just combine like terms, and you'll see it. You'll see it in the prepared notes. And then for f, we're saying f of x divided by g of x. So now it looks like f can be factored, right? Let me see. Can we factor f into something like this, where we have x and x? Because my second sign is positive, I know my two signs are the same. Because this first sign is negative, that means the larger number is negative. So then if they're the same and the larger number is negative, then they should both be negative. Sorry, negative and negative, right? So then we're looking for two numbers that multiply to give us 8 and add to give us negative 6. And I think that's 4 and 2. Okay. So now if we said f of x divided by g of x, the x plus 2's are going to cancel, and we're just going to be left with x minus 4. And the main thing here, because we're dividing by x minus 2, that means x cannot be equal to 2. Because if x were 2, it would generate a 0 in the denominator in the original equation, and then, we'll be led astray. Oh, you have to forgive me. I am struggling. Like I usually take a nap before I meet with you all, and that just did not happen. I made some cabbage. It turned out really good. I'm pleased with it. But it had a twofold effect. I didn't get my nap, so like my energy's low, and I have a full belly. So now it's like I got the itis, so I'm like, damn it, I didn't find that. So it's okay. Let me see. Where do we leave off? Keep going. So I gave myself space, but I didn't really need it. Let me see. I think we got all these. Wait a minute. There was something else I wanted to show you. Yeah. Okay. So we got these results. So I want to showcase this A and B in the calculator just to confirm before we go forward. Okay, let me go to my y equals, and let me type these two in. Okay, so my f is x squared minus 6x plus 8. So x squared minus 6x plus 8. My g is x minus 2. Okay, we can at least do a and b in the calculator, right? Just to confirm. We actually, yeah, I think we have it here already. Let me do the keystroke so you can. Yeah, let me just redo this. So for A, I want to say f of 4 minus g of 4. Okay. So I'm going to go to, on the right hand side of the calculator is the clear button. Left of that button is a button that says VARS, it's short for variables. I'm going to click on that button. I'm going to go to the right to go to Y variables. I'm going to click on number 1 to open up the functions. And our f was y1, so I'm going to call on that function. I just pressed 1. So we want to do what? F of 4. So when x is 4, and then we want to say minus g of 4. So we put g in the second slot. So if I go to variables, y variables, number 1 for function, and I mean, it's in the second slot. So I'll press 2. We want to say g of 4. We should get a result of -2. Okay. So then B is f divided by g of 3. So we're really doing f of 3 divided by g of 3. So I'm just going to recall on the one I just submitted, change the 4 to a 3. And it needs to be division, right? F divided by G. We should get a result of -1. And then for C through F, we can't do that in this calculator. So, okay. I think I did. Sorry. So then if I go back to view single page, okay, now it's behaving properly. Okay, let me see. They got the -2, the -1. I think we got the rest of these: x squared minus 5x plus 6, x squared minus 7x plus 10. And then you can see F foiled out all the way out. So they expanded and then combined like terms and they got the result. And then I think we got the same thing for F. Let me check on you guys in Zoom really quick. Get the student. All right. So composition of functions. So if f and g are two functions, the composition of the function f with g is written as f composed g and is defined by the equation. Let's go. F composed g of x just means f of g of x, right? Where the domain of f composed g consists of those values in the domain of g for which g of x is in the domain of f, right? So again, this symbol is called the composite function, right? And it's read f composed g of x just means f of g of x, right? So what this symbol means is the second function inside the first function. So then a common error that students tend to do when they see this symbol, you know, sometimes students multiply that. This is not multiplication, right? This is not multiplication, you know, nor is this multiplication either, right? So none of this is necessarily multiplication. What it means again is the second function inside the first function. You see it here. Okay. And we have I think it seems like we can do this much faster. We have an example where we'll talk more about the domain of a composite function in just a moment. So this slide is like a pictorial representation. Say you have your original domain, your set of input values. You pass them through the function g, and then you produce your output values g of x. Then what we're going to do is take those output values, pass them through the function f, and then generate f composed g. So then the domain of f composed g comes from the domain of g, which is back over here again. We'll see in a couple of examples on how to find the domain of a composite function. But there's this 3-step process that I do to find that. Okay. So given this f and this g, find each of the following functions. Okay. So working on part A, we have f composed g of 1, right? So what does this mean? This means the second function inside the first function. So f of g of 1. Okay. Then that means f of, now g is x plus 1. So this means f of x plus 1. Okay. All right, so then this means, so what we're going to do is just write f of x like normal, but replace each x with the green thing. Okay, so f is x to the power of 3, but again, each x is replaced with green thing. Okay. Oh, I keep forgetting that. I don't know why I keep doing that. I know why, because I'm sleeping. Right, I forgot to plug in when x was 1. So then 1 plus 1 is 2. That ends up being f of 2. Okay. So this is really 2 to the power of 3. And I think that's 8. Okay. All right. Let's try B. So then for B, we have g composed f of 1, right? So what does this mean? Again, this means the second function inside the first function. So this means g of f of 1. Okay. So this means g of, now f of 1 is going to be 1 to the power of 3, which is just g of 1. And just for the sake of space, I'm going to move this on to the next line. So then g of 1 ends up being 1 plus 1. Sorry about that. Okay. And then for C, f of -1. So that just means the second function inside the first function. So the second function is going to be f of -1. Okay. So then what's f of -1? It's going to be -1 to the power of 3. Okay. So then that's just going to be f of -1. Because a negative raised to an odd power is going to be negative. And then f of -1 is going to be -1 to the power of 3, right? That's negative. Okay. Okay. So we got 8, 2, and -1. So there's our 8. So we got our 8, our 2, and our -1. Right? So given this f and this g, find each composite function. Okay. I think I'm going to leave this one. I'm going to leave this one as an exercise for you, and I want to work on the next one. And this is just a typed version of that. Okay. Given this f and this g, find f composed g of x and its domain. Okay, yeah, let's talk about this one. Okay, let's start off with part A and f composed g. So then f composed g of x, this means f of x, no. This means f of g of x, right? F of g of x. Okay. So this means f of, now g of x is what, 1 over x? Okay. And our f is x plus 1, so this is going to become 1 over x plus 1. And keep in mind, oh, well, okay, so now this is the example where we can showcase the 3-step process to find the domain of a composite. So when I'm trying to find the domain of a composite function, I do the following. 1, I find the domain of the inside function. And then 2, I find the domain of the simplified function. And then 3rd, I take their intersection. Those 2 sets. Okay. So if we're going to do that, so first let's find the domain. In this case, our inside function for part A is g, so we need to find the domain of g. Okay. If we look at g is the reciprocal function, 1 over x. So in general, the domain of a rational function is all reals except any x that makes the denominator 0. So the domain of g is everything except 0. Okay, so that's the domain of the inside function. So then next, let's find the domain of the simplified function. Okay. So the simplified function we got was 1 over x plus 1. So then for that, its domain is going to be what? All reals except x equals 0. So we want everything except 0. And then the third, for the intersection, I didn't really intend for all of this to be purple. Okay. A set intersect itself as itself, right? So x not being 0 intersection x not being 0, it's just going to be x not being 0. Right? I was kind of hoping to get another piece of information in here. I'm out of space. Okay. So if we want to capture the solution set that's everything except 0, then let's go here. The far left would be negative infinity up to 0. And then we want to go from 0 to infinity. Okay. Infinity in this context always gets a parentheses because we do not want to include the 0. 0 gets a parentheses. And we're going to combine these with the union. Right. So that's part A. Let me see the time. Okay. Let me see. I think I need to get a copy for B. Yeah, I'd like to work on B actually. Let me get a copy. Copy and delete. Paste. Okay. So let's work on part B. So we're asked to find G compose F of X and its domain. So G compose F of X. This means the second function inside the first function. So this means G of F of X. Okay. So this means G of now F of X is X plus 1. So what we're going to do is rewrite G like normal, but replace each X with the future thing. So this is going to be 1 over X plus 1. I think that's as far as we can take that. There's a little bit more to this narrative, but we're going to put a pin in for right now. So then for, again, the 3-step process for the domain, first we're going to find the domain of the inside function. In this case, it's going to be the domain of F. So we'll put a 1, find the domain. Domain of F of X. Okay. That's fine. The domain of F, if we look at the original, F is just X plus 1. So that's going to be a diagonal line. Y-intercept is 1 and the slope of 1. So this domain is all reals, right? It's just a line. Every X is accounted for. So we'll say negative infinity to infinity. Okay, so that's the domain of F. Then let's find the domain of the simplified function. Okay, so the domain of the simplified. Our simplified is 1 over 1 X plus 1. So again, in general, the domain of a rational function is all reals except any x of x in the denominator 0. So when we look at our simplified function, it looks like when x is what, -1, we get a 0 in the denominator. So what that means is we can use any real number except x equals -1. So we want to throw out the -1. Okay. Just a moment. Man, she's like living it up. She went to the spa yesterday. Now she's at the lake. She's doing it right. So that 30 seconds. Okay. So then the final step is we want to take the intersection of these two sets, right? So then 3, take their intersection. All right. So the first set is all reals. Let me write it like this. So then, I don't know why I did curly brackets. Okay. Let me see. So we're doing all reals, which is -infinity to infinity, intersection, everything except -1. All right, so I'm just going to abbreviate it like this. So the whole line, intersection, everything except -1, what do they have in common? Everything except -1, right? It basically collapses to that second step. So then in the interval notation, now this is our result simplified here. And then so x not equal to -1 is just going to be everything except -1. So we can do like this. So say here's our -1, right? If we want everything except -1, we want everything to the left of -1. We want everything to the right of -1. But we're going to use parentheses because we don't want to include -1 itself. So then if we translate this graph into interval notation, the far left is going to be what? -infinity up until -1. And then we want to go from -1 to infinity. Infinity always gets parentheses in this context. Again, because we do not want to include -1, the -1s get parentheses, and we join these two sets by union. So then that should be the domain for B. So again, to kind of a quick recap, first we find the domain of the inside function, then we find the domain of the simplified function, and then we take the intersection of those two sets. Let me see, for A, we got 1 over x plus 1, everything except 0. So notice we have our 1 over x plus 1, and the domain was everything except 0. And then for B, we got 1 over x plus 1 in this form, and we got everything except -1. Let me see. Oh, okay. This will probably be our last one. Let me see. Yeah. Well, this one is, and it's fairly quick. We got out a little bit early today. So far with combining function and composite functions, we have been, given two functions. We either add the two we combine the functions, or we take composition of functions and we get an answer. So then here we want to start with that answer and work in reverse, right? So we're asked to write this H as F compose G. So there's more than one correct answer here, right? You just have to, it just depends on how you set it up, right? You just want it to be so that when you say F of G of X, you get this result. So let's start with our inside function. Like one possible inside function or one possible g, we could say let g of x be what, 2x squared plus 1. So if that's our inside function, then our f of x would need to be 1 over the square root of x. So that's one potential, right? Another possible result for g, I'll do it in a different color. So g could be square root 2x squared plus 1. And then if that's the case, our f of x would need to be 1 over x. Okay. Man, there are more. This is just a showcase a couple of different possible outcomes, all right? And so if we look at our prepared notes, so they let g be 2x squared plus 1, which is what I think we did initially. So then our f of x would have to be 1 over the square root of x. So then, I have it there. Okay. So I want to leave this as an exercise for you. Are there any burning questions? This is also in my pre-recorded lecture. So if you wanted to see this, it's there. Are there any burning questions before we go our separate ways? Okay. Let me make a copy of this available. Let me make sure it's the right folder. 23 traditional notes. Yeah, this is right. Okay. So when this bar finishes loading, you'll receive a copy of anything that you saw me writing. And if there aren't any burning questions, we're actually going to go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of your day. We're going to meet back on Wednesday, same time, same place. Take care, guys. Peace.
Quick question. When is our midterm? And is it like it's an online midterm?
Yeah, it's really just exam 2. It'll become available this upcoming Sunday, and you can earn full credit for 7 days. It's due basically 7 days later.
All right, I appreciate that. And also, I'm still like I'm having like trouble like getting the access code and like buying the actual Pearson's lab. So like what should I do for like extensions and like deadlines and stuff?
So for did you purchase it from the bookstore?
I called them, but they never got back to me. And I couldn't go over the weekends because they were closed. So
yeah, you might want to try to get up there. They might be open for like another hour, maybe. But you might want to just go there and talk to somebody because it shouldn't really take that long. I don't know where the delay is coming. But you might want to go up there and talk to them. And then once you get access, just connect with me and we'll try to get to the bottom of it.
I appreciate it. Have a good one.
Any other burning questions? Going once, going twice. All right, gentlemen. I'll see you Wednesday, same time, same place. Take care. Peace. Like I said, the next